Hello. My name is Nicodemus Mombela. I'm a teacher of mathematics and physics here at Afri School. And now I want us to have a discussion on the topic of force. That is a topic in Form 1. And we're just going to go through this topic. So we are asking you to join us and even invite others who would be interested to be part of this discussion. And so that we may revise what you know about force, and maybe if there's something else that you don't know, that we can discuss and refresh your knowledge. So we are going to discuss the force, and the beginning part of this is that we're going to define what a force is. Definition. And we say that force is a push or a pull. So anytime there is a force, a push, or there is a pull, then we know that there is a force involved. Then the SI unit, and what we mean by SI is the System International. That's a French word, but in English is a international system of units accepted everywhere as standard. So the SI unit for force is, we call the Newton, after the famous Sir Isaac Newton, who studied force quite a great deal and developed classical mechanics. Now, we are going to talk about the types of forces. And here, there are very many. We'll mention as many as possible. And then we'll be looking at each one in turn. Just give us some brief information about that type of force. There is the magnetic force. Magnetic force. This kind of force is non-contact, because with your experience with magnets, you know a magnet is able to attract a metal even when that metal is at some distance from it. So we say it's a no-contact force or non-contact. And so you are able to attract. For instance, if you have a magnet here, this is north and this is south, and then you bring another magnet, a bar magnet, and this one is north, this is south. So you will notice that there is an attraction between the two magnets, and you can actually physically feel that force. So there is a whole topic on magnetic or magnetism in Form 2, but at this stage, we are only just naming the forces. So magnetic force is one of them. The other thing about a magnet is that when you hang a magnet and then you suspend it in air, you will notice that this magnet will continue turning until finally it rests in a meridian or in an axis that we call the north-south meridian, the north-south of the Earth. Earth, that is where it's going to settle, because our Earth is also a magnet, and therefore when it settles pointing in the north-south direction, it means that it's also being affected by the magnetic force of the Earth. So that is one type of force, the magnetic force. The second type of force is what we may call gravitational. Gravitational force. Now, what is this gravitational force? This one has to do with two bodies that are physically near each other. So you can talk of mass 1 and mass 2. For any two masses that are close to each other, there is a force of attraction between them. Whether you're even talking of two people, it's only that the forces involved here are so small that you cannot feel them. But now when you bring a big mass like the Earth, and then you bring another small body next to it, say a person walking on the Earth, now you are able to feel that force, because the Earth is a very big thing. And since this force, gravitational force, is determined by the masses of the bodies involved, we are now able to feel that gravitational force by the Earth. So basically, when we talk about gravitational force, we are mainly referring to the Earth because it's the one that exerts gravitational force on them. How are we able to feel the force? When you jump up, you are going to be forced to go down, or you will have to find yourself going down. Or when you throw a stone up, you're also going to see it coming down because it is being attracted by the Earth. So that is the gravitational force. And we are able to find the weight by multiplying the mass of a body times the gravitational constant. G is found to be 10 newtons per kilogram. So when your mass is, say, 50 kilograms, you now multiply by 10, and then you're able to get your weight in newtons. So that gives us 500 newtons. So that is the gravitational force that gives objects what we call weight. We are discussing about the types of forces. So far, we have mentioned two. The first one, we mentioned the magnetic force, and then now we have talked about the gravitational force. Type number 3 is electrostatic force. Now, this one, any child or any person who is interested in some physics phenomena may have someday rubbed a pen. You rub a pen, and then now when you place it above some, say, pieces of paper, you find that there's attraction. The papers are picked up by that charged pen. Charging means you just rub it against maybe hair or some soft material. And then you find that when you bring the pen, it's going to attract the pens up. Now, this force is what we call electrostatic force. And in this force, you are able to find that bodies get charged when they are either rubbed against some soft material, or sometimes it can be done by induction, but that one is a topic that will be dealt with later on in Form 1. There's a whole topic on electrostatics. But in electrostatics, the basic thing we can say here is that there are two types of charges. And for lack of a name, we will just call one of them positive, and the other type, we call it negative. And now you find that positive will attract a negative charge, but a positive will repel a positive charge, and a negative charge will repel a negative charge. So out of it, we get what we call the basic law of electrostatic, which states that like charges, not poles. Poles is when you're dealing with magnetism. Like charges repel, and like charges attract. But as I said, this is a topic that will be dealt with in very fine detail, very deep detail, because it's a topic on its own in physics Form 1. And then still continuing with the types of charges, we have another charge that we call upthrust. Again, this is something that has to do with experience. You find that when you try to lift up something that is inside liquids, like say water, it is much easier for you to lift up. You can have a simple experiment. Here we are discussing what we call upthrust force. You can weigh something in air. So here you have a spring balance, and you're weighing something, an object. And here you may find that the weight here may be, let's say, 20 newtons. But then when you weigh it while it is immersed in some liquid, this is a spring balance, so now you're now weighing it. But this time it is immersed in some liquid. You can even say water. Water is a very common liquid, so you can use that one. Now you find here that the weight of this, or the force, is now going to be less. The spring balance will be reading less, say 15 newtons. So where did the 5 newtons go? Here it was 20 newtons, here it is 15 newtons. What has happened to the weight? We usually say that there is a apparent weight and there is the real weight. So here when you weigh it inside water, there is some loss of weight. This loss of weight is caused by a force that acts upwards. So it counteracts the real weight of this body. Therefore, you find that the real weight decreases. So it is actually lighter to lift something that is inside water than if you just weight it weigh it when it is physically suspended in air. So because of this, we now can conclude that there is a force that acts inside liquids and it acts upwards. And this one is called upthrust force. This is a topic that will be dealt with in very deep detail in Form 4 in a topic that we call floating and sinking. So here at this stage, we're just going to mention it as a type of force that exists in nature. Then force number 5 is a force that we call frictional force. I'm not following any particular order, I'm just mentioning the forces that are there. Now, when you have, for instance, a slope, just some wooden plank of wood, and then you make a slope of it, and then you pull this body while it's resting on this plank at some angle, you can call angle theta, then you pull it upwards. You'll find that you have to exert some force before this plank begins to sliding upwards. So that as soon as it begins to slide, then you can note the force. The force may be 40 newtons. Now, if you, excuse me, if you have another body and you pile it upon this, let me have another diagram. You pile two of them, like of the same weight, same nature, and then you pull again using a spring balance. Here, you may have to exert much more force before the arrangement begins to slide up. So here you may end up maybe using something like 70 newtons. Now, that measure there, what the spring balance will be reading at this stage, as soon as the sliding begins, you are actually reading the frictional force that exists between the block of wood and the surface below it. So that is now called the frictional force. You are able to physically measure it by using a spring balance. Now, you may find that this frictional force, number one, it depends on the nature. Some surfaces are very rough, so you find that there is much more friction. Like if you touch the surface of a sandpaper, that surface is very rough. That means there is a lot of friction in it. So this frictional force depends, number one, on the surface or nature of the surface. The other factor that determines the frictional force or the magnitude of it is what we call the reaction. You see, when you place these two blocks, you're going to have more frictional force here than if you just had one. So when you place this one, there's, apart from the two weights, there's also a force acting against for it. Whenever you have an action, there's also a reaction. So this reaction is the one that is increasing the amount of frictional force. So the frictional force here, we are saying, number one, it depends on the nature of the surface. The rougher the surface, the more the friction. And then the other thing is the amount of force that exists between the two surfaces, what we are calling the reaction. So that is about, we can say there's a great deal that can be discussed about frictional forces, but that is a topic again in Form 3 when you discuss the Newton's laws of motion. We are still discussing the types of forces that exist, and we have mentioned 4 so far. We now go to